Shall I start, madam?
Yes, sir. Just a minute. I just welcome the participants.
Okay.
Delightful welcome and very good evening to one and all present for the day 4 of the 1-week national level virtual faculty development program on research methodology and statistical tools used in research, organized by PG Department of Commerce in association with IQAC and Research Cell of the college. I, Nabhishri, PG Coordinator of St.Teresa's Degree College for Women, will be the host for today's session. First and foremost, I would like to welcome the eminent speaker, Dr. D. Kumaresan, sir, our resource person for the program. I wholeheartedly welcome you, sir.
Thank you, madam.
Also, I welcome all the participants for the 4th day virtual faculty development program. So today, we are in the 4th day of the faculty development program, and today's topic is sampling and hypothesis testing. This is one of the challenging tasks in the research. So let us start the session. I'll now hand over the session to the resource person. Over to you, sir. We are waiting to listen from you.
Good evening to one and all present in this platform for the 4th day of 1-week faculty development program organized by St.Teresa's Degree College for Women. I'm indeed very happy to be the resource person on this day 4. Madam Naveshri told that this is a challenging job, challenging task for every researcher, that is sampling and hypothesis testing. Let us see how the challenge is converted into opportunity at the end of the day. Thank you very much. Let me share the presentation now. So day 4, 5th June 2022. Today we are going to discuss about sampling and hypothesis testing. So what is a sample? Why we are conducting sample study? We know pretty well the common meaning for population. Population is the universe, the whole set of people or the whole set of organization for which or from which we are going to conduct our research study. So, population is the whole elements. All the elements of the universe are called population. Generally, the population will be of large size. Sometimes even it could be infinite. The size of population may be infinite or unknown, quite large and unknown. In that case, it is not advisable or even possible to conduct the study among the whole population. All the elements of population cannot be included for the study. And moreover, it is not required because the characteristics of the population may be represented by a few elements of the population. So we select certain elements of the population for being included in the study. So those who have included and selected from the population are called samples. So sampling is a technique used to select the sample respondents or sample units out of the elements of the population and it is done for the purpose of the study. So it is called sampling. We consider that the sample represents the whole universe, represents the whole population. The characteristics, the opinions, the perceptions, the behaviors, the attitudes of the entire population could be measured, or they may be reflecting by the samples. That is why it is always better to conduct study among the samples. Suppose if the population size is very small and we are conducting the study among all the elements or all the members of the population, it is called census study. If all the members of the population are included in the study, we call it as census study. But in fact, the population size is not quite small. Since it is larger or unknown or even infinite, we go for sampling study. Instead of census study, we are going for sampling study. So in the sampling study, as I told you, only a few members from the population are selected. Now the question is, number one, how many members of population are to be selected for the study? The number of members from the population to be selected for the study is known as sample size. It is called sample size. So the next question obviously is how to determine the sample size. Number one. Then question number two. Number one, how to determine the sample size. Whether it is 40, 50, 100, 250, 300, 400, 500, 700, 1000, 2000, whatever it is. There must be some limited size. So what is the size? So sample size is the number of sample members selected from the population. Number one. Number two, on what basis these members are selected as samples? So there must be some criteria. There must be some method for selection of samples. So what is the method? What is the appropriation method for our study? So that is different. So different methods are there. How to select that particular method for the present study? So these two are the major questions regarding sampling. Number one, how to determine the sample size, and number two, how to select the samples. Here, first we have to determine the sample size. So I have given you few steps in determining the sample size. So before determining the sample size, you define what is the population size or number of people in the universe. Universe doesn't mean that the population of the country, population of the city, population of the districts, or population of the world. It is not like that. Suppose if you are conducting study among the customers of Ford car in Bangalore city. Customers of Ford car in Bangalore city or Bangalore district. In that case, population is the number of users of Ford car in Bangalore district. Understand? The population does not mean the population of Bangalore city or the population of Bangalore district. Or if you want to say that, sir, population of city is the population, sir. Then what is sample frame? Sample frame. So from the population, we cut a part that is called sample frame or sampling frame. Sampling frame is the number of users of Ford car. For this purpose, the sampling frame number of users of Ford car is to be considered as population size. Okay. Then from the population size, how to determine the sample size? If suppose there are more than 6,000 users of Ford car in Bangalore district, that is population. 6,500 users of Ford car. So whether you are going to conduct the study among all the 6,500 users of Ford car? No. So out of these 6,500 users, we are going to select a few users. So here, in order to determine the sample size, we have to define the population size first. Then we have to determine the margin of error. To what extent or to what margin the errors are permitted. Generally, we say that it is a significant level, like that we are saying. So margin of error, what is the permitted margin of error? Suppose if you are taking 5% level of significance, it is said to be margin of error. Then determine the sample, confidence level. To what extent you are confident. Again, 5% level of significance means 95% confident. 95% confident. Then we have to predict the expected variance. What is variance? Variance is the square of standard deviation. Square of standard deviation. From that, we have to finalize the sample size. Let us see how to finalize the sample size. See, this is one of the most popular methods of computing the sample size. See, N is the population size, Z is the Z score, E is the margin of error, and P is the standard deviation. Or sometimes probability of pass. Let us take like that. So here, Z square, for Z square, we have to first compute the Z score. For 5% level of significance, what is the Z score? So Z score is suppose 1.96. If you go to the normal table and check the Z score for 5% level of confidence, it is 1.96. So Z square here, the formula is formula for computing the sample size is Z square into P. See, P is the probability, I told you no, or standard of deviation. Suppose 50%. Normally, the expected level of probability is 50%. So 0.5. Then into 1 minus P, again it is 0.5 divided by E square. E square means margin of error. Suppose margin of error is 5%. It means 0.05 square. So here, this is the numerator part. And denominator, 1 plus Z square into, again, P into 1 minus P divided by E square into capital N. Capital N denotes population size. Small n denotes sample size. So if suppose you want to use this formula, you need the population size. Because one of the elements of the formula is capital N, that is population size. If the population size is unknown, this formula cannot be applied. So Z square value, we know it's general. P possibility, percentage or probability, we know 0.5 generally. E square, we know 0.05 square. So only thing is N, that is capital N or population size. This is the most popular and most widely used formula for determining the sample size. So it is very simple, and it is it can be used only when you know the population size. So if the population size is unknown, if the population size is infinite, then this formula cannot be applied. Whether the population size is small or large, it is immaterial. If it is known, then we can use this formula. Then another formula is there. Look at this. Very simple definition. Z square into P into 1 minus P by E square. See here, capital N is eliminated. So if population size is unknown, or if the population size is infinite, then instead of the previous formula, we can use this formula. Z square, as I told you, 1.96 into 1.96. Then P into 1 minus P, 0.5 into 0.5. See the difference? P is 0.5. E is 0.05. So Z square into 0.05 into 0.05. I mean 0.5 into 0.5 divided by 0.05 into 0.05. This is another formula used for determining the sample size. So this can be used when sample size, I mean population size is unknown or it is infinite. That's all. Now you see, there are certain online sample size calculators. SurveyMonkey is there, RawSoft is there, calculator.net is there, surveysystem.com are there. These are the websites available in the net for determining the sample size. That is, it will ask you these components, these elements of a formula. If you give the input, this online calculators will calculate the sample size automatically like this. See, this is one of the online calculators. See, population size is given, confidence level is given, margin of error is given. Look at the sample size. crores and crores. I don't know how many zeros are there. Is it not? How many zeros are there? No, it is immaterial. Confidence level is 95%. Margin of error is 5%. Look at the sample size, 385. 385. Look at a glance of the formula. See, if the population size grows largely, then the sample size is saturated. It becomes constant at 385. At 385. If it is 10 lakhs, if it is 20 lakhs, if it is 50 lakhs of population size, if it is 1 crore or million, thousands of millions, billions, trillions, no issues. It becomes constant at a stage. So if you apply this formula, you can compute and you can find that if the population size is more or quite large, then the sample size is limited. It becomes constant. Whatever input you are giving for the sample size, you will be getting 385. So 385 is the ideal minimum size of sample. It depends upon the researcher. Better you can determine the sample size as 385 itself. Or if your research supervisor advises, let it be rounded figure. There is no such criteria for odd figure or even figure. It is not like that. 400. For making the calculation better, you can go for 400, 500, like that. So that you can get the accurate results. One thing. Another thing, I said if you fix the sample size more than this, that is more than 385, you can get more accurate results. I said, okay. But at the same time, please keep in mind, if you increase the sample size abnormally high, then again there is a problem of result. Again, accuracy cannot be determined. So better let it be up to 500 or 600. That is also very high. But in certain surveys, certain predictions, since the population is quite large, we determine more sample size. That is also there. For academic purposes, it is better to limit the sample size. So let it be a minimum of 385. Now let us see what are the different sampling methods. So once we have decided the sample size, we have to select the sampling methods. Sampling methods may be broadly classified into two: probability sampling methods and non-probability sampling methods. What is probability? Probability means chance of happening. If something is happening, it is called probability. Here, in the case of probability, equal opportunity is to be given for all the members of population for being selected. So it is implied. What is the meaning of probability sampling? In the case of probability sampling, all the members of population should be given an equal opportunity of being selected as samples. It implies that the probability sampling methods can be used only when you know the population size. Because equal opportunity means what? If there are 100 members in the population, each element of member of the population has the opportunity or the probability of 1 by 100. Is it not? If there are 1,000 members in the population, equal opportunity 1 by 1,000. If 1 lakh members are there in the population, probability is 1 by 1 lakh, we can say. If suppose we do not know the population size, we do not know the population size, how can you determine the probability? How can you, if you don't determine the population, probability, how can you give equal opportunity? So it's my suggestion that if you know the population size, you can select the probability sampling methods. Otherwise, you can go for non-probability sampling sampling methods. Again, I'm telling you, if the population size is unknown or infinite, then better you can go for non-probability sampling. Or even sometimes the probability is known. You can go for, the population size is known. Even then you can go for non-probability sampling methods. But for the research studies, particularly for working out on research papers or on thesis, better you can go for probability sampling methods. It is only accepted by the examiners. So what are the most popular sampling methods under the probability sampling? There are 4 major methods. Simple random sampling method, then systematic random sampling method, then stratified random sampling method, then cluster sampling method. Simple random, systematic random, stratified random, and cluster sampling. Number 1, simple random sampling. It is very simple. It is very simple. Under this method, like lottery method, we are selecting the sample respondents. How many members are there? No problem. You write the names of all the members of population. All the members of population. Then put it in a bowl or put it in a box. What is your sample size? Suppose 385. You pick 385 chits from the bowl. That's all, over. There is no criteria. There is no order. There is no procedure. It is called lottery method. The names of all the members of population are written in chits, in separate chits. They are put in a bowl. You are picking up the sample size. That is, 385 means 385 chits. 1,000 members are there. You are picking 385 over. It is called simple random. So it is very simple. You would have understood. Then come to systematic sampling. Here also, it is like the previous one, but one difference is there. Instead of writing the names in separate sheets, we can write the names of members of population in a single sheet. You are writing names of all the members of population together. One thing, you have to write the names either in ascending order or in descending order. You collect the names of members of population. If you go for simple random sampling, write the names in sheets in separate sheets and put it in a bowl. You collect one by one. You pick one by one. Whereas in the case of systematic sampling, you write all the names in a single sheet or together, either in ascending order or in descending order. What is sample size? Suppose if the sample size is 400, just for the sake of easy understanding, I'm telling you, sample size is 400. What is population size? What is population size? Suppose population size is, for example, 4,000. Let it be for easy understanding, I'm telling. Population size 4,000. Sample size 400. You do one thing. You divide the population size by the sample size. What is population size? 4,000. Divide 4,000 by sample size. What is sample size? 400. So 4,000 by 400. What is the answer? 10. Okay. Now you take the sheet. You select you mark or you divide the 4,000 members into 10 members of each. Into 10 members of each. 1 to 10. Then 11 to 20. 21 to 30. 31 to 40. 41 to 50. 51 to 60. Like that. So how many tens will be there? 400 tens comes to 4,000. Is it not? Total 4,000. We have divided 4,000 by 400. So each division or each unit contains 10 members. So how many units will be there? 400 units. 400 is the sample size. Now what you have to do is, from each unit of 10, you have to select 1. From each unit of 10, you have to select 1. So which one is to be selected? In the first set of 10 or in the first unit of 10, you can select any number according to your choice. According to your choice. You may select 7, 4, 9, 3, anything, any number you can choose. Only for first 10, it is allowed. It is according to your discretion. Okay. Suppose if you have selected 6 from the first 10, you have selected the 6th item or 6th member. Then from the second unit onwards, you have to select the next 10th item. Next 10th item. Which is the first item you have selected? 6th. So what is the next 10th? You just add 10. So 6th means next 16th. Then third one, 26th. Fourth one, 36th. Fifth one, 46th. Like that you have to select. So 6th, 16th, 26th, 36th, 46th, 56th. How many units, how many members would have been selected? 400. So over. It is called systematic sampling. Then come to stratified random sampling. In this case, again, we are dividing the population into smaller units, like systematic sampling. In the simple random sampling, no division of population. All are put together and we have selected the samples. But in the case of systematic, the selection is being made systematized. So we have divided the samples, the population, into different units. We have arranged it in ascending order or in descending order. In the case of stratified random sampling also, we are dividing the population into different units. In the case of systematic sampling, each unit contained equal number of elements. Equal number of elements, that's all. But here, the population is to be divided into subgroups. We do not know how many groups will be formed. Earlier we know there will be 400 units, 400 subgroups. Here we do not know how many groups are to be divided. And here the units are divided on the basis of homogeneity. On the basis of homogeneity. That is, the members of population having uniform or same characteristics are divided into one unit. So the division of subunits or subgroups under the stratified random sampling is made based on the homogeneity of members. Very tall boys, short boys, very short boys, or fat boys, thin boys. Understand? So each division should be made based on common characteristics or uniform characteristics. Then understand, from each unit of each subgroup, you have to select samples. From each subunit, from each subgroup, you have to select samples. See, have a quick look of this. Simple ring. This is simple random sampling. We have selected. See, look at this. There are some green shirt persons and they are wearing red shirts. Some people are wearing red shirts. See the shades given at the foot. Look at this. The shaded persons are selected as samples. So in the simple random sampling, there is no criteria. Any person, see, look at this. First person selected, fourth person selected, then 5, 6, 7, 8, 9, 10, 11th person selected, then 12, 13th person selected. No criteria. Red shirt or green shirt, first, second, third, fourth are not. No criteria. This is simple random sampling. See, look at this. In the stratified random sampling, The top box is the population. Top box. It contains three types of persons. One is square, then triangle, then circle. So three types of people are there. See, now we are dividing the population into three units. Like squares are there, circles are there, then triangles are there. Each unit is called stratum. Again, singular stratum, plural strata. So singular stratum. Each subgroup is called stratum. That is why we called it as stratified random sampling. See, look at this. In the first stratum, all the squares are divided. So square is the common characteristics. Here all the circles. Here all the triangles. Likewise, we have to divide the population. And look at this. This is a sample. Sample is drawn from square, drawn from circle, drawn from triangle. This is for understanding, it is given. How many circles are drawn, how many triangles are drawn, it is immaterial. It is immaterial. But we are selecting squares, circles, and triangles. It is called stratified random sampling. When we come to the cluster sampling, there also we are dividing the population into subgroups. In the stratified random sampling, we called each subgroup as stratum. In the case of cluster sampling, we call the subgroup as cluster. So cluster means everything is added. So there is no homogeneity required for dividing the groups. Look at this. 15 members are there in the population. This is first cluster. It contains all green shirts. This is second cluster. It contains all red shirts. Third cluster, 2 red shirts, and first and 2 red shirt, third green shirt. Here, first and the third green shirt, second red shirt. Here, first green shirt, second and third red shirt. So is there any homogeneity? Here homogeneity is there. Here also homogeneity is there. But this group contains heterogeneity. Fourth one is also heterogeneous. Fifth one is also heterogeneous. So in the case of cluster sampling, homogeneity is not required. If it is homogeneous, no issues. So how to divide? Normally, cluster sampling is made when the population is spread across a large geographical area. One is in Mysuru, one is in Bangalore, other is in Dakshin Karnataka. Is it not? Like that, in different places, in distant geographical locations, the population members are situated. In that case, we can go for cluster sample. So what is the difference between stratified random sampling and cluster sampling? In the stratified random sampling, one condition is there, that is, we have to divide the stratum based on homogeneity. In the case of cluster sampling, homogeneity is not required. And in the stratified random sampling, you have to select samples from all the strata. From each stratum, you have to select the samples. See, look at here. Second cluster is selected. Fourth cluster is selected. So here, divisions are made, subgroups are made, not based on homogeneity, one thing. Number two, samples are not selected from all the clusters. You can select any cluster. You can select any cluster. In the case of stratified random sampling, you have to select samples from each stratum. Who you are going to select from each stratum is immaterial. Again, you can go for simple random sampling or systematic random sampling for selection of samples from each stratum. Here, we eliminate certain clusters because it is divided, it is situated in wide geographical location. So this is, for example, this is Dakshin Kannada, this is Mysuru, this is Tumkur, this is Bangalore, this is some other area like that. So we avoid these three clusters. No issues. We select only these two clusters, Bangalore and Mysuru, for example. Okay. That is called a cluster. Again here, whom we are going to select as samples, that is immaterial. For this again, from this cluster, you can select any number of persons. Maybe based on simple random or systematic random sampling. So these are the different methods of probability methods. Probability sampling methods. Then come to the non-probability sampling methods. Convenience sampling, judgmental or purposive sampling, snowball sampling, and quota sampling. In the case of convenience sampling, like simple random sampling, there is no criteria. There is no specific order. You can select any person according to your choice. That is called convenience sampling. Then what is judgmental or purposive sampling? If suppose there is a study conducted among the final year UG women students. Understand? Final year UG women students. There are more people, more students in the college, more degrees, UG, PG, MPhil, PhD. Both boys and girls are there. You have to select samples. That means you come to a judgment based on your previous knowledge that this girl is a final year UG student. You know she is a girl. That is okay. Right? Or he is a boy. Okay. Whether he is a final year student, final year UG student or not, you do not. But if you know and you select that person, it is said to be judgmental. Or sometimes you are conducting a cultural program in your college. You have the previous knowledge that who are able to dance, who are able to sing songs, who are able to play musical instruments. You know, based on your previous knowledge, previous experience, you know. In that case, you are selecting Miss A, you are selected. Miss D, you are selected. Miss Q, you are selected. Miss R, you are selected. Like that, you are selecting. There is no criteria, one thing. Right? There is a purpose for you. That is, you are selecting girl students for cultural programs. So cultural program is your purpose. Cultural program is your purpose. And that too, if you are conducting classical dance only, there may be several dancers among the girl students, but your purpose is classical dancing only. So you have to select those girls only. If it is made based on judgment, simply by your experience, by your knowledge, you know she is able to dance classical dance. You are selecting. That is said to be judgmental or purposive selecting sample. Then come to snowball sampling. See here also, look at this. This is very simple to understand. We do not know what is snowball sample, and we do not know who can be the tentative sample persons. But you know only one person. So look at this. You know this blue shirt person, blue shirt wearing person, you know. He is the right person to be selected as sample. You ask him to refer certain persons with the same characteristics that are to be selected as sample respondents for your study. Look at this. Blue shirt person recommended this person. This person recommended this one, and this one. Similarly, blue shirt recommended this person. He has recommended this person, like that. It is called snowball sampling. So here, you do not know all the sampled persons. You know only a few persons. You select them. You ask them to refer others, like network marketing. Is it not? So in that way, if you are selecting the sample, it is said to be snowball sampling. Then you come to the quota sample. Here, we are assigning certain quota. Pretty well in railways, quotas are allowed for elderly people, for children, for differently abled, for women. Separate coaches are available, no? So what is the number of elements allowed for each quota? Sir, for this quota, this much is allowed. 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 Like that, based on certain quota. For example, for elderly people, aged more than 60 years or more than 70 years. So this much seats are available. For women, this much seats are available. For ex-servicemen, this much seats are available. For differently abled persons, this much seats are available. It is called quota sampling. See here, the quotas need not be equal, understand? The quotas need not be equal. It is called quota sampling. And finally, one more sampling is there, multi-stage sampling. Here, in each stage, the other things are eliminated. Instead of selecting, we are eliminating, and few categories are selected. See, in the case, countries are selected. See, for example, if this is the map of any continent, these are there are several countries, and only these countries are selected in the first stage. Then, see, this is a country. In this country, certain segments are selected in the second stage. See, this is a stage from which certain households are selected in the third stage. Then from each household or from certain household, certain individuals are selected. So countries, segments, household. So one by one, eliminated. It is said to be a multi-stage sampling. That's all about the sampling. Then we move on to the hypothesis testing. Hypothesis is nothing but an assumption. There are two types of hypothesis, null hypothesis and alternative hypothesis. While determining while formulating the hypothesis, we should understand the significance. Where should we use the word difference and where should we use the word relationship or association? This is what null hypothesis and alternative hypothesis. The actual test begins with considering two hypotheses. They are called null hypothesis and alternative hypothesis. They contain opposing viewpoints. If null hypothesis says there is no difference, alternative hypothesis says that there is a difference. So they are having opposed viewpoints. See, these are the examples of null hypothesis. There is no significant difference between this and this. Suppose you are comparing two variables. Understand? If you are comparing two variables, in that case, you should not use the word difference. In that case, you have to use the word relationship. There is no significant relationship between gender and satisfaction. Gender and satisfaction. There is no significant association between age and satisfaction. There exists no significant relationship between education and satisfaction. See, education is a variable. Satisfaction is another variable. Gender is a variable. Age is a variable. So here we are comparing two variables. In that case, we have to use the word relationship, association, or anything like that. Suppose if you are using the word difference, difference can be used when you are comparing groups of a variable. What is groups of variable? Gender is a variable. Gender is divided into male and female. Satisfaction is there. If you are comparing gender and satisfaction, you have to write there is no significant relationship between gender and satisfaction. If you want to compare satisfaction of male and satisfaction of female, then you can write there is no significant difference between male and female respondents regarding satisfaction. Like that you have to. See, null hypothesis, there is no significant, there is no significant, there is no significant. Alternative hypothesis, there is a significant, there is a significant, there is a significant. That's all. Now outcomes. If the H0 is true and you are accepting, it is correct decision. If H0 is true, H0 means null hypothesis. If H0 is true and you are rejecting, it is an error. That is called type 2 error. If H0 is false and you are accepting, it is said to be another error called type 2 error. If H0 is false and you are rejecting the H0, it is also correct decision. See, H0 is true, it is accepted, correct decision. H0 is false, it is rejected, it is correct decision. If it is true and you are rejecting, it is type 1 error. If it is false and you are accepting, it is type 2 error. Please look at a glance of this. Level of significance. When to reject, when to accept. If the p-value, that is probability value, is less than 0.01, if the p-value is less than 0.01, you have to reject the null hypothesis and accept the null hypothesis. The result is significant at 1%. Because p-value is 0.01. If the p-value is 0.05, reject the null hypothesis, accept the alternate hypothesis, the result is significant at 5%. If the p-value is greater than 0.5, null hypothesis is accepted. There is no need for rejecting the alternate hypothesis. You can straight away give the result. There is no significant relationship. That's all. So this is a criteria for acceptance or rejection of null hypothesis. That's all about the hypothesis testing. So sampling is now simple. Hypothesis is also happy now. So with this few words, I would like to conclude with a great sense of gratitude and thanks to the organizers as well as the participants. Thank you one and all once again. Now it is left for you. The forum is kept open for you to ask any questions. My dear participants, if you have any queries, you can ask now. Thank you very much.
Yes, sir. Exactly as you told, the sampling is now become simple and hypothesis has become happy with your excellent presentation.
Thank
So
you very
now
much.
I request the participants to post your questions if you have any. Yes, the participants are asking that can we get recorded video? Definitely, all the sessions are recorded and you will be getting the video on the last day along with the PPTs. The resource person is sharing the PPTs to me every day. So you will be getting the PPTs as well as the recorded videos at the end of the FTP. So now I would like to get some queries from you. Yes, we have a question here, sir, from Karthika.
Yes,
Sir,
please.
can you please explain me what is cluster sampling and hypothesis once again?
Okay. In the case of cluster sampling, Karthika, thank you very much for your wonderful question. I told you no. In the case of cluster sampling, the samples are divided. The samples, the population elements are divided. Not based on homogeneity. Not based on homogeneity. In the case of stratified random sampling, as I told you, we have selected the samples based on the homogeneity. But here, there is no need for homogeneity. If it is there, then okay. If it is there, then okay. If there is no homogeneity, there is no problem. It is normally used when the population is spread across a huge geographical location, a huge geographical area. In that case, we follow this method. Like I told you, no, these are in the in this particular district. These are in this district. Like that, the samples are located in different geographical locations. Okay. Then each subgroup is called clusters. Each subgroup is called cluster. Unlike in the stratified random sampling, the samples are not necessary to be selected from each subgroup or from each cluster. Only a few clusters. First, the total population is divided into different clusters, and you select only a few clusters, and the samples are selected from those clusters only. That's all. So that is the advantage of a cluster sampling method. So this is what about cluster sampling. Then regarding the hypothesis. Hypothesis is an assumption. Normally we have two hypotheses, null hypothesis and alternative hypothesis. See, null hypothesis is not a negative hypothesis. Please understand. Even though it contains the word no, it is used as neutral. That's all. It is used as neutral. Is there any, suppose if I'm asking you, do you have any disturbance or do you have any pain? You are saying that, no sir, I have no disturbance. No sir, I have no pain. That means, no pain means, is it negative? No, you are normal. If you don't have any pain, you are normal. Like that, if there is no difference or if there is no relationship, it is normal, it is neutral. For that purpose only we are using null hypothesis. Moreover, null means nil. No, null means nil. If suppose, like in the alternative hypothesis, you are telling there is a difference, then you are confident that there is a difference. Then what is the need for conducting a study? Right? So that's why we are using the null hypothesis as there is no significant difference. Then we test the null hypothesis by means of certain tests of hypothesis that we are going to discuss in the forthcoming sessions. Okay, that's all about the hypothesis. Then,
Sir, I have a question.
yes, sir.
Sir, when should we formulate the hypothesis?
Formulation of hypothesis. When you want to analyze, inferential statistics are used. In that case, we have to formulate the hypothesis. Before analyzing, you have to formulate the hypothesis. Once you decided once you have framed the objectives and decided the variables, what are the independent variables? What are the dependent variables? See, the analysis can be divided into two. That is a descriptive analysis and inferential analysis. In the case of descriptive analysis, there is no need for hypothesis. Only in the case of inferential analysis, you are comparing two variables and you are testing the relationship between variables. In that case, only you have to formulate the hypothesis. The hypothesis are to be formulated before performing analysis. Okay, Ashif.
Thank you, sir. Thank you, sir.
Welcome.
Thank you, sir. We have another question from Manju Boria.
Yes.
What is significant value? What is power test?
Yeah. See here, significant value. I told you, that confidence level is there. Then error of margin is there. Here we call it as significant value. See, level of significant is different. Level of significant value is different. But the number is same. That is, in the case of 5% level of significance, the significant value is 5%. That is 0.05. 5% level of significance means 0.05. Why this level is considered? See, significant level means the possibility of accepting the null hypothesis. We are computing the probability value. I told you, margin of error. Margin of error is the permissible limit of error. See, in statistics, you cannot say that my result is 100% accurate. You cannot say. Some fractions of difference may be there. So there may be certain limit of error. While computing the standard mean, standard deviation, there is an error. While computing the mean, there is a standard error. So whatever you do, there may be certain errors. So mistakes are committed by you. Errors are made out of the calculation. That is the difference. So errors are inevitable. Errors are inevitable. That is why we permit, we allow certain margin of error, certain limit of error. Normally, in most of the studies, we take the level of significance as 5%. If suppose in a strict manner, you want to have that level of significance, it is 1%. Normally 5%. In a strict level, it is 1%. The same is regarding the confident level. I told you no. If level of significance is 5%, confidence level will be 95%. If significant level is 1%, confidence level is 95%. I mean 99%. That means if level of significance is 5%, error is permitted up to 5%, and you are sure that your calculation or your answer or your finding is absolute or accurate to the extent of 95%. 95%. That is why we call it as significant. It may be different from one study to another study, one researcher to another, one problem to another. Moreover, we are testing at 5%. The result shows that the p-value is less than 0.01. Then you can proudly say that it is significant at 1% because the p-value is less than 1%. So you are getting 99% confident. So that is what significance or significant value. Regarding the power test, that is used to calculate, as I told you, that margin of error or significant level, that's Z square is calculated. No. For that purpose, we are using power test. That's all. Majubaria, got the answer?
Yes, sir. Hope that was clear. Thank you so much, sir, for your positive response. As we also got the response in the chat box that it was clear. And I don't find any other questions in the chat box, and none of the participants have raised their hands as well. So with your permission, let us wind up the session for the day, sir.
Yes, ma'am. Sure. Thank you all once again. Let us meet tomorrow. Good night.
Yes, it's happy to see a good number of participants even on Sunday, and this shows the interest of the participants towards the learning and acquiring knowledge.
Yes.
The learning process takes time. Do not hurry. We have still 2 more days to go. So dear participants, we will all meet tomorrow exactly at 5:30 and learn about the advanced research, especially when it comes to statistical tools. So please join us back tomorrow at 5:30.
In fact, I was 150 kilometers away today. I rushed to join the meeting, and just by 5:25, I have arrived at home and joined the meeting, fortunately. And moreover, heavy rain is there here. Anyhow, without any interruption, we have completed today's session. Thank God, and thank all the participants.
Thank you so much, sir. Thank you so much for your time and efforts.
Thank you.
Thank you once again, sir.
Okay,
so, dear participants, we will all meet tomorrow exactly at 5:30. Thank you, one and all. Thank you so much, sir, once again.
Thank you.